Hey, Bear Scammon here at the Eugene Science Center, and today I'd really like to talk to you about our Van de Graaff generator. Now, a Van de Graaff generator is a really fancy name, named after its inventor for a static electricity generator, which is just a type of electricity that builds up in one spot and isn't flowing. It's not in a current. So what's going to be happening is this belt inside of our Van de Graaff generator is going to be going down to the base of our machine. It's going to be rubbing against basically what could be considered a carpet. It's going to be picking up electrons from that carpet and depositing them here at the top of our electron dome. Now, those electrons are going to be building up and building up and building up, and electrons really do not like to be stacked up right next to each other in that much of a density. They're going to be looking for any avenue for them to escape. Now, the two best places for electrons to escape to, in this case, is going to be back into the base of our machine from where they came. That's going to be a low electron density area after they've been siphoned away. Now, the best way to get into that is through my electron wand. It's got this wonderful metal bulb that's just the same type of metal as the top of our Van de Graaff generator, and it's got a wire leading down to the base. This is a really, really easy, very highly conductive material that allows those electrons to pass very easily. Now, the other place that it really wants to escape to is back down to the ground. The ground is an infinite sponge for electrons. Those electrons are freely welcomed. There's a huge amount of space for them to spread out, and that would be a really great place for them to be too. So for my safety, so that I do not get shocked by this Van de Graaff generator, I'm going to be standing on my plastic stools in the back here, and this is going to raise me off of the ground. And since plastic is relatively non-conductive, it's not going to let me have any type of interaction with the ground that the electrons might want to flow through me instead of anything else. Now I'm going to call off the lights for a second, and we're going to be turning on our machine. And what's going to happen is the electrons are going to build up into our Van de Graaff generator, and once they have reached critical mass, they are going to try and jump to our electron wand in quite a little spectacular show. Thank you, lights off. All right, we're turning on the machine. We'll hear a whirring. Now you may notice that there are these tiny little lightning bolts coming off our machine. And as the closer I get to the Van de Graaff generator, the higher the frequency, the faster the number of lightning bolts appear, the brighter they appear, in fact. Those are giant packets of electrons jumping through the air, exciting other atoms and other electrons, causing them to give off photons. Now, if I bring the electron wand a little bit further away, you'll see much bigger lightning bolts. These are much bigger packets, and they need more time to charge up very big packets of electrons before they can jump through the air, which is why they're happening at a shorter rate. If I could have some lights on. Now, the lightning bolts are just one feature of our Van de Graaff generator. One of the cool things that can happen is remembering that electrons don't like to be next to each other. So what I've got over here is I've just got a little foam ball on a string. And I'm going to ask for my assistant to come over here. Christina, if you'd come over here and help me with my safety. Christina is going to be holding the electron wand so that when the Van de Graaff generator needs to be turned off, she can decharge it and turn it off for my safety. So what's going to happen is I'm going to be holding this foam ball just at a distance from the Van de Graaff generator. Now, there are plenty of electrons here in the foam ball, and since it is very light, it's going to want to be repelled by all those electrons. It doesn't want any more electrons in it, and it's going to try and get away from that. And you're going to see that in just a second. So Christina, if you wouldn't mind turning on the Van de Graaff generator. Now, as soon as Christina takes the wand away from the Van de Graaff generator, those electrons are going to build up in the dome and are going to push this foam ball away. We're going to see in 3, 2, 1. Now, not only are they being repelled by the dome, they're also going to be attracted to the wand. So if Christina would please put the wand about a foot that way, you'll see that the ball would very much like to be next to the wand. Those electrons are moving through the air into the foam ball and being drawn towards that wand. All right, thank you, Christina. If you would turn off the machine. Now, I have just a couple of little styrofoam balls, and I'm going to do something here that requires me to touch the Van de Graaff generator. So, Christina, once again, if you would be here for my safety, I'm going to once again remove myself from the ground on my plastic stools, and I'm going to touch my hand to the Van de Graaff generator while it is on. It's going to fill me with electrons, fill these little balls with electrons, and they're not going to want to be in my hand anymore. So, Christina, if you would please turn on the Van de Graaff generator, and then hold that wand as far away as possible. So long as the electrons do not jump out of my hand in a fast rate, it will not be painful for me. Little science fireworks right there, people. All right, and I'm going to take a step down and a step back, and the electrons are going to flow out from my feet. And after that, Christina is going to turn off the machine. In 3, 2, 1. Wonderful. Now, one of your experiences with static electricity may have been with a balloon and maybe having your hair stand on end if you've just gone down a plastic slide. Now, hair standing on end is a very wonderful feature of this, and what I've got here is actually a beaver pelt. Beavers are very well known for a very thick pelt that keeps them very warm while they're swimming in the water. And we're going to just see what happens here. So I'm going to turn it on. Those electrons are going to fill the beaver pelt, and they're going to extend all those hairs, and they're going to want to get away. So let's see what happens in 3, 2, 1. So much do they want to get away that they, in fact, took off. I'm going to try and put the wand at just such a distance that I can make this beaver pelt dance a little bit. Now, each one of those hairs is standing right on end because they don't want to be near any other electrons. Now, there's one final thing that I want to show you, and it's going to require Christina, because Christina's got much better hair for what we're going to be doing. Christina is going to be standing on our plastic stools in the back to insulate her from the ground. Christina, would you please put one hand on the Van de Graaff generator, and we're going to just see what happens to a human who is fully charged with electrons. So, we're going to turn the power on, and we're going to take the wand away in 3, 2, 1. Christina, would you give a little hair shake? Now, Christina, does that hurt at all?
No, not at all.
No, you might feel a little bit of a tingling as those electrons are building up inside of your body. But so long as they do not jump out of you at a rapid rate, it is not harmful. You'll notice that also all those electrons are spreading out throughout every inch of Christina's body. And she has got a lot of them stuck in her hair. And those hair have all those electrons and they don't want to be near each other at all. And so even in the back, and Christina, if you would actually take your hand and move it around your hair, it should repel the rest of your hair. A little bit. And that's because Christina's hand is also filled with those electrons, and they're repelling the electrons in her hair. All right, Christina, when you feel safe, please take your hand off the Van de Graaff generator and then step down. Thank you very much. Now I lied a little bit. I had one last experiment for you. Hey, and we're back with our last experiment, and you'll notice that I've got some safety gloves on, and that's mostly for me to hopefully not get horribly shocked by our last experiment. Now, the last experiment I've got going on for you is our halogen light. Now, our halogen light is filled with halogen gas, and those gas particles inside of this light, when they're exposed to large amounts of electricity, through either end excite the gas molecules inside of the light. And when they do that, it gives off lots and lots of photons of that light that we get to see. And so what we're going to be doing is we're just going to be turning on our Van de Graaff generator and we're going to be shocking it and see what happens. So if we could have Christina come over here and get the wand, and the lights are coming off. And Christina, when you are ready, please turn on the Van de Graaff generator. Now, those electrons are once again going into that electron wand. They're completely ignoring everything else, but as soon as Christina takes it away and I bring the light closer, we have our own little in-home lightsaber. Now isn't that cool? So once again, those electrons are jumping into that gas, and as they're passing through that gas inside of the light bulb, they're exciting the outermost electrons of those valence shells of those halogen gases. And when they're doing that, those electrons, when they calm down, they need to release a lot of energy. And they're doing that in the form of light. Now isn't that cool? All right, Christina, if you would please turn up. And I'm gonna step down. And thank you so much.